Hi, thanks for coming out and joining me today. I'm Paul, one of the co-founders of NewEra Software, and I'm here to talk to you about the rebranding of IPLCheck to IPLCheck AI. So let me go ahead and share my screen and we'll get started. First, just a few PowerPoint slides to get through to set a little background for you. The first thing that I want to point out is that at the end of this month, we will make available what I'm about to discuss with you, along with support for 3.2 across our entire product offering. So I think if you are a current user or you are planning a proof of concept, you'll want to make sure that you get in touch with technical support for ICE 19, which will be the latest version as of the 1st of October. But as it relates to IPLCheck AI, let me emphasize that this is a tool that now runs in concert with the IBM Health Checker for ZOS. It is image focus in its entirety, but essentially running only under the Health Checker. That close association with the Health Checker allows it not only to perform full inspections, but also to detect exceptions that are being reported by the Health Checker itself. In addition, it discovers dynamic changes, that is, those changes that are affecting the configuration that have not yet been hardened back into your PalmLab component. Now, IPLCheck AI, just like Image Focus, generates an inspection log that contains a trace of all of its actions, all of its prompts, all of its responses, all of its findings. And these logs can be quite large. For a typical system, somewhere between 18 to 20,000 records can appear in a trace in the log itself. Exploring that, getting in there and digging out what's important, particularly some things that might be hidden, that are configuration insights that you would like to know about, or perhaps compliance concerns, can be difficult. So IPLCheck AI has been enhanced with a command line interface that allows you to access the log through a dashboard that I'll demonstrate in just a few moments. Of course, the kind of AI we're talking about here is sometimes referred to as OF AI, old-fashioned AI. It's a rule-based retrieval environment in which our data scientists have continuously trained the model over time with their own experience, the experience of customers, the application of new PTFs or new versions of ZOS, and allowing users to modify that training for their own environment through a set of filter rules. Now, all of the training is release specific. So whether it's for PalmLab or JES or VTAM or TCP/IP or CICS or a whole suite of IPsec tools, the training is release specific. Once the model is trained and called into action, the initial prompt, either discovered automatically or given by you, typically the same thing that would be given at an IPL, unit address and load parm, the system begins by essentially interrogating the operating system to ask it for information. That information, gathered through program prompts, is evaluated by each of the individual rules, and each of those individual rules then results in a finding. It's either an error, a warning, a notice, or some informational concern. All of this is deterministic, it's all fact-based, it's all transparent, and can all be traced back into the log itself. Obviously, there are always discussions about the findings of these until it settles down to a point where you have confidence in it, but we're prepared to stand behind it and work with you to make sure that that confidence is truly built up. So, as I mentioned, the logs can be quite large. And up until this point, up until IPLCheck AI, the only way to truly determine what had been found was to simply go to SDSF and then interrogate the individual checks that were found in the check log. And the two that we're specifically interested in are the dynamic change check and the operating system check. But today, in addition to our web portal, we also have ICEChecks, which is essentially a dashboard into the log itself that allows you to explore the log from any TSO command line. So let me stop sharing this and go to a 3270 session, and we'll begin to explore it. Here we go. Share. All right, so here I am in a 3270 session, and I'm going to go ahead and log on, or I am logged on. So what I'm going to do is go to M.5. I'm going to go to CK, which is the command to display the check outputs in SDSF. And I'm going to issue a find NEZ, which is the prefix for all the NewEra checks, and we'll show you a bunch of those in just a minute. But as you see, there aren't any available now at this point in time. So what I need to do is go start IPLCheck. Having a hard time getting my fingers on this. Huh. Okay. So now IPLCheck is up and running. You can scan down and see if that's true. Yep, there it is. So it's up and going. By the way, the installation of this is really easy and can be shared. Common installation can be shared across any number of systems in the same sysplex that happen to be sharing DASD one for the other. So one installation could result in any number of systems actually being monitored by the health checker with IPLCheck AI. Okay, so CK, go on. Now, so here are all the NewEra checks. Some of them are still continuing to run. The ones that we're interested in, as I pointed out earlier, that come as part of IPLCheck AI are the dynamic change inspector, as well as the OPSIS inspector. The others are what are considered advanced functions and come as part of additional licensing beyond that, which is provided by licensing IPLCheck AI. So we'll have a look here, see if this one's finished. It is. So this is dynamic change inspection. And you can see that the different components that we are looking at are the APF list, the BPX list, BPX mounts, the link list, LPA, and system symbols. And if we find something that says, hey, what's in memory right now, which is managing those components, is different from what is in your PARM lib, then we're going to report a difference. Now, at this point, this is all the information that can be provided because there are limitations as to how much information can be passed back to the health checker to be reported through this interface. So this is what's available. And now we can go down to the OPSIS inspector and have a look at it. And we can see there's all kinds of information here. Now I'm on a test system, and so there is very little security limitations for me because I'm the only person on the system. But as we page down here, sorry about that. We can see a number of security violations here, protection inadequate, a load data set wasn't found on a volume that it was specified on, The data set should not be defined unless it actually exists. And so there's all kinds of different rules that are applied and violations which are viewed and reported on. Many of them are security violations, but also a large number of them will be just simply problems in syntax or values or referential integrity or other kinds of issues or problems that may cause concerns and possibly could prevent an IPL at some time in the future. So PF3 back. So the takeaway from this part of the presentation is that IPLCheck is easy to run, can be shared across multiple systems. IPLCheck AI provides two checks, dynamic change and operating system. There are more available and advanced functions. That the health checker presents that information in a substantially brief form. So now we're going to go and take another look at something else here. So we're going to go to 3.4, and we're going to look at the IPLCheck log that contains the trace. Now, the system I'm on has a name of SOW1. So when I do that, I can find the log. Here it is. There are some other data sets that are created that contain reports and history information, etc. The log itself is here. And if I move down to the bottom, we'll see how big this guy really is. So in this particular case, this is 18,101 records long. And so to evaluate this historically, the way IPLCheck was set up before we rebuilt it and rebranded it to IPLCheck AI, this was a daunting task. Exploratory data analysis of a log of this size is quite an effort. So what we've done is if you go to the command line here and type TSO $ command line interface, comma, CK, we have our own CK command, and press enter, it's going to go out and find the log for the system that it's running on, and it's going to present the results of that log presentation in the form of a dashboard. And you can see the dashboard now before you. So there's lots of information here. There's no question about it. It in of itself will take a bit of study to clearly understand it. But all the relevant parts of the inspection and all of its findings, plus the changes that can now be defined within IPLCheck AI, are available here for you to deal with. Starting at the very top, here's the log again. So this is what we looked at earlier under 3.4, so there's no real reason to go to 3.4. You can just simply log on to TSO, go to the command line, type in that command structure, and this will be available to you on any system that is running IPLCheck AI. There are a number of different components here. Obviously, starting at the top is the date and time of the last inspection, if you would, the running of the IPLCheck, the log, what it found, errors, warnings, notices. You put the cursor under any of the white stuff and press enter, you'll get a report that will show you exactly what it found. And it does that by grouping the messages together so that all the messages that are similar in nature can be viewed at once. And you can see all the different messages here, data set problems, secondary extents. I've got a bunch of information messages here. Excuse me. Again, grouped together by messages so that you can see all of the specific type of message, no matter where it occurred. In the very last case down here, one of these messages occurred on line 1948, and another one occurred on line 863. And so this would give you some perspective of where they show up in terms of the overall inspection report itself. We can see from here some history information about the inspections and findings. So here are the various times at which the Health Checker ran and IPLCheck AI was executing. So most of these are in September. We had one in June. You can see the errors, warnings, and notices. You can see all the information that is critically important to understanding the state, status, and changes that are occurring to the health of a given image. So how old the IPL is. So we had up to 104 days, and then we had a new IPL. We went to 2. We haven't had any errors. We have the same warnings over and over again, as do we have notices and informational messages. We have no changes, dynamic or otherwise, in symbols, APF, BPX, mounts, LPA. We have a few links, RNL, and changes in the configuration itself. And I'll show you how we set up this process for managing those changes. It's more specific information. What is the load characteristics of this guy? So this is all the information that you would need to understand exactly what this system was and how it was IPL. And the normal stuff, unit address, load parm, and any filtering information like VM user ID is all specified here. The load number. Again, this background information, this may be a system you're not very familiar with. You could be an auditor, you could be a system programmer who's been called in to actually troubleshoot a problem, and you need to get up close and personal with the profile of the system itself. This is an ideal way for doing that. Dynamic changes. Well, we showed you this earlier, but here are the ones that deal with LPA. So they weren't just adds, there were some deletes that went on in there. There's 6 overall changes, but 5 of them were deleted members or modules from the LPA list, and then there was 1 addition. And then here are the members that those modules may have come out of or need to be, or would impact if you wanted to make an update to them, to bring the static system in sync with the dynamic changes. We can create a baseline, really easy to do. The baselines are are formed with containers. I'll show you one. This is the IPL path in a container. And you can see the container begins and the container ends, but you also notice there's a token here. And that token tokenizes the information that's within the container. So if someone were to come and manipulate this baseline, then at the time at which there was a comparison, there would be an error message that was produced that said, hey, there's something wrong with the baseline itself, and you either need to figure that out or you need to renew it. Renewing the baseline is just as easy as clicking reset the baseline, and we'll do it for you. Here's the changes that are taking place. Here's one change. And let's see what it is. So we had 1 delete and 3 different line items added to an IEA SIM member. And in those cases where things are added, we can actually highlight those lines for you so that you can see what they are. So give you some insight as to what it is you might uh, either want to continue to have added, or perhaps you might want to go ahead and re-delete those as the case may be. There are a number of pre-programmed prompts down here against excuse me, against the trace itself. Some of the more interesting ones would be like prevailing keywords and values. These all share a common header. This particular report highlights the IEASys keywords and not only shows you each keyword and whether it was defined or whether it was described by default, but if it was by default, then if the default value is available, then the default value is shown as well. You can see in some cases we don't know exactly what the default value is, but we did in the first case of Alex, we did again in AXR, and again for catalog and SAE. So these are kind of interesting because sometimes what these default values are, these are values that are used to define the members that will prevail following IEA SYS processing are elusive, and you don't really know what they are. So this is laying it out for you. This is telling you the member that these values came from. Quite a bit of detail here. Data sets by volume mapping. We have 156 data sets spread across 15 volumes. But you can see the various data sets, how many, excuse me, the various volumes and the number of data sets on each, 17 in this case on C5 Sys1. You can see the allocation and the disk organization, the number of members, if that's available, and whether or not there's any access privileges that have been specified for the data set itself. For example, in this case, the access to these data sets requires read authority. So this is a good place to check the security settings. It's a good place to check for the disk organization of various data sets. So lots of, again, specific information here. Again, you might be an auditor, you might be a guest, you might be responsible for this, and exploring this data often reveals information about the configuration, perhaps hidden from view, that can be relevant to your understanding of what's going on. Of course, this is a very powerful environment, and so there are guardrails that can be put in place here to actually define users as administrators, just straight up users and auditors, and they can be protected by a facility class profile. This is optional and can be currently turned on or turned off as the case may be. Additional IPSec information. So these are optional license tools that will give you better insight into the security that's being provided by them. Here's a summary of that. Okay. So I guess you probably by now, the takeaway point from this is that the logs are big. They contain all the trace information. And this dashboard gives you access to all that trace information to allow you essentially to begin your exploration in a very directed way. There are options here for all of the reports. You can print them, you can copy them, and you can also email them directly from inside this environment to others in your group. So if you see something that requires action, you could do that immediately by just simply checking mail. Perhaps you want to do something with Unix system services. You'll get a report, and you PF3, you'll get the mail interface, and you can enter your own message, enter the addresses of the people you want to send it to, and you can send the mail now. And if it goes successfully, it will give you a message that says, yes, the email was sent successfully. And so if your message was, take a look at this, I think it's important, then you don't have to copy this out, put it in your email system, and go in some other way. Of course, this all means eyes on glass here at this point, but the better point might be for those of you that just simply want to do some monitoring. So if monitoring is what you're really interested in, that is monitoring of the log and all the trace information that's in it, there are three different kinds of reports. There's a dashboard report, which will produce a dashboard for each of the systems that is connected into this particular setup for IPLCheck AI. There is a summary of that called a findings report that, again, is hooked to all the systems that are hooked to IPLCheck AI that we are looking at. And then there's a specific health checker report. But in addition, there's also some specific information about the health checker itself. So if we look at that, these are all the check exceptions that are currently in play within this system. And so if we were to look at this one, we not only see that there are exceptions, but we begin to see a history beginning to build up that we could, if we were lucky enough, to spot a trend in here that might be significant to us. If something went from a low severity to a medium or high severity, that could be significantly important to us. Here's a good example of that. This is a pageant inspection that one of our tools is doing, and its exception on the 19th was low, but now it's considered high, and more explanation of that would be necessary. So you could just simply click under NEZ pageant inspection, and you will get that detailed inspection of what we found that we believe has gone wrong. Of course, that's more eyes on glass, but you can get this same kind of report simply by putting a check here or one here. Now, you can run the scheduling for these reports daily, weekly, monthly, and in this scheduling process will control their creation and delivery. Or you can uncheck all of these and they will run under the control of the IBM Health Checker for ZOS. The time where I'm at is 12:31, so I'm going to go ahead and set this for 12:33 and update this. So it's dynamically updating all the configuration settings that are necessary for sending that report. And when it's done, I'm going to be the only person that's going to get a copy. Now, when reports are actually sent via email, all those players who are identified as admins, the 4 of them here, will get a copy of the report if they are checked. But others can also be targeted to receive reports by simply adding their name to a mail list that is for daily reports, weekly reports, or monthly reports. And so the boss may only want to see a report once a month. Maybe your supervisor wants to see one once a week. And maybe you want your teammates to see one once a day. And you can do that here by simply adding their names to the list and checking them to make sure that they get the appropriate report. Okay. Delivery can be by email. It can also be an alert to ServiceNow by just simply checking that, or it can be delivered via FTP, all three, or if you don't want email, just uncheck that. If you don't want FTP, uncheck that. And so a simple summary message will be sent to ServiceNow saying there is an indication that there is a difficulty been encountered in the inspection or in the exceptions that are being reported on, in this case, SOW1. Okay? All right. So let me PF3 out of this. It's always checking to make sure that you update the configuration, or if you plan to, if you accidentally updated it, you will have a chance just simply to say, no, I don't want to update it. And that's the way that particular function works. So let me now stop sharing this and share my email if I can. I'm sure it's here somewhere. Well, okay. Maybe I didn't have it up. Here it is. Okay, so here are the three reports that we selected. They came up. Here's one of them. Well, you probably can't see that. Maybe move this over a little bit. So here's a report, and here's a summary of the dashboard. And in my particular case, there are, I believe, 10 or 11 systems that are actively sharing the same IPLCheck AI installation that are in the SysPlex that is in my system. So everything that we have, we'll put little notations in the margins to indicate that there might be issues that need to be addressed. This is the absolute highest level of detail. This is the next level of detail, which is a summary. So you see all the same bits of information, the age of the IPO, what level of ZOS, what version of image focus, what did we find, what is the age, is there a verifiable backup, is there a baseline, what's its age, are there any changes, are there any dynamic changes for the current cycle. This is the current cycle. And this is the cycle right before that. So if you track this on a regular basis, you'll be able to see not only what's happening now, but be able to deduce what changes may have taken place. And then this last one is for the exceptions that are being reported by the IBM Health Checker for ZOS. And the same process basically exists. Either we have a report, which we have in this case, or we didn't have a prior report for that particular check, as is the case here, for whatever reason, I'm not sure why. Okay, so you can set these up, they can go, and those will come to you on a schedule that you set or on a schedule that you set with IBM Health Checker for ZOS. Okay. All right. Well, that brings us to the end. I want to thank you for coming out and sharing your time with us today. I truly appreciate it, and I look forward to any questions or comments you might have. You can always reach me at NewEra use my email address, prr@newera.com, or simply send an email to support@newera.com. Hope to see you soon. Have a great day and look forward to ICE 19 and ZOS 3.2. Bye-bye.